Hello folks, welcome back to Feature Vector with your nerd in a hurry, Poddick Joshi. As always, the views in this podcast are my own and not those of my employer. Feature Vector was recorded in Gadigal land. In this episode we're asking, is AI going to replace filmmakers? We'll bury the lead here and say, the answer is no. But getting to why is a trip through the nature of human creativity itself. This episode is a vodcast and can be equally enjoyed in audio as well as video form. To understand AI and filmmaking, we need to begin by examining the relationship between art and technology. Technology and art have travelled hand in hand for as long as we've had both. Tools for art making, dating back 100,000 years, were discovered in South Africa, and there's arguments to be made that the desire to make art drove the human adoption of tools, and vice versa. Contemporary art history itself came from a scientific approach in the 15th century, and the study of tools and techniques were as important as the actual art itself. Coming to movies. The Academy Awards came out of the Academy of Motion Pictures Arts and Sciences. The early Oscars featured toolmakers as part of the main awards from the 1930s to the 1960s, and are still recognized in an adjunct ceremony to the main ones every year. The point is, technology and art are deeply intertwined. Tools in art are a mechanism to take human intent and magnify it. Central to this is understanding that without a human to drive them, the tools aren't meaningful. There's a persistent myth that advances in technology are going to kill art and artisans. From today, painting is dead, cried Paul Delaroche, a painter, at the demonstration of the first daguerreotype, an early photograph, in 1839. In the end, though, photography didn't kill painting, but it'd be disingenuous to deny that it didn't cause a seismic shift in the field. In the same way that a good set of brushes and paint and canvas don't automatically make a good artist, a good camera doesn't automatically make a good photographer. Time and again, it's the skill and the expressiveness of the operator that makes compelling art. In the words of the legendary proto-street photographer, Henri Cartier-Bresson, it is an illusion that photos are made with a camera. They are made with the eye, the heart, and the head. The contemporary version of this, before our current AI moment, is that computer graphics are ruining cinema. As a computer graphics toolmaker, of course I am biased, but I'd make the argument that blaming tools here is missing the point. It's one of taste rather than function. Against a backdrop of persistent warnings that computer graphics would destroy cinema, 2D and 3D computer tooling have become an ordinary and ubiquitous part of the filmmaker toolbox, applied across human-scale dramas and blockbusters alike. Complaints about using computer graphics in film come down to then taste rather than function. We often talk about using the right tool for the right job, and despite their versatility, sometimes a CGI approach isn't the right solution. The tools might not be up to task, or there's not enough time to use them properly. In that case, could another tool have been used instead? Maybe the story could have been adjusted to tell the story beat without the tools. There's a pattern in the early life of new computer graphics tooling, where it is a solution in search of a problem. It's a shiny new toy with so much potential, and experimentalists will go out of their way to give it a go, whether it's appropriate for the storytelling or not. I'm going to go with the framing assumption that AI, and the machine learning that drives it, is a tool. A powerful one, but a tool nonetheless. Is it going to replace filmmakers? To reflect on that, I'll start by retelling my own attempt in answering that question. In early 2016, I was captivated by the idea of style transfer, an approach pioneered by Gaddis et al. In their seminal paper, A Neural Algorithm of Artistic Style. In this technique, any given image, a photo, or whatever, could be redrawn in the style of another image, for example, a painting, using machine learning. So I started out just by gluing things together and seeing what happened. Style transfer worked on individual images. So to get it working on video, what if I just split a video into individual frames and then style transferred each frame and then combined the result back together? Turns out this was surprisingly fun. I took two things that were stylistically unalike: the symmetrical perfection of Stanley Kubrick in 2001: A Space Odyssey, and the chaotic explosion of shape and color of Picasso to create 2001: A Picasso Odyssey. It was silly and absurd, but it was at the right time to capture a moment in AI, and ended up showing at a few film festivals alongside the now perennial question, can computers make art? Not long after this, I got a call from a producer in LA, David Shapiro, who was working with Kristen Stewart on a directorial debut, Come Swim. The concept for this film was based on a watercolor painting that Kristen had made, and it had sparked a creative question. Could style transfer be used to re-express some of the scenes in the movie in the style of the painting that Kristen had done? When you get that kind of call, you say yes, and then you spend the next 3 months working out how you're going to make it happen. Drunk on hubris from a Picasso Odyssey, I'd, incorrectly, romanticized the capabilities and the idea of style transfer and AI, and I just assumed that the task was easy to do. Frames and painting go in, movie comes out, right? But now I was on a real movie in a real production. And it turns out I was wrong about AI being plug and play for creative work. So wrong, in fact, that we ended up writing a paper about how wrong we were. So what happened? Taking machine learning techniques that work on individual images and just assuming that they're going to work on a video sequence is a super bad assumption. We run into a key problem here that doesn't have a simple solution, which is what is sometimes called poor temporal stability or sometimes poor temporal coherence. It turns out that even super tiny changes between input images, the kind of small changes that you'd see, for example, in frames in a video, can lead to dramatically different results when an ML algorithm is applied to those images. This meant that there was a significant amount of sizzle in the result. There could be significant differences in rendered color and even shape from frame to frame. It's actually kind of a cool effect that in some cases work really well with the narrative that you're trying to tell, but I think that in the vast majority of cases, it's a bug, an error, and we're still trying to find ways of working around it. In a more general sense, another problem with ML techniques that transform images, let's just for argument's sake call them ML filters, is poor local control. These techniques take hints about what you want them to do, and then maybe it will do it the way you want them to do it. So if you want a good result, then we return to the age-old story about humans creatively using tools, using human intuition and discrimination and a sense of taste and aesthetics to pick the best result out of several attempts the computer has made. We can get better results by adding more handles for directability. These handles are often priors, bits of pre-computed or specified information that help explicitly guide the machine learning process. Tools like ControlNet allow you to pre-process the video to highlight what is important, for example, edges, and use that to guide the generation. It's worth noting that these still don't address temporal sizzle. There are various ways of improving the result with artistic intervention using warping tools like EBSynth. But as the level of human artistic intervention increases, the less it looks like some kind of automated AI technique, and the more it looks like traditional video animation work. And you know what? That's okay. Deepfakes have overcome this issue with a great degree of success by using a prior that computers can now track very well, the human face. It's super limited. As soon as someone turns their head to the side, it falls apart. Consumer-level deepfakes are starting to look pretty decent, but they still don't look good. And they still require tons of human intuition, steering, and taste to get them there. High-end deepfakes, like what's being used on this year's Indiana Jones movie, are even further down that line. The results here look great, but it doesn't make it any less true that the starting point was ML. But there were hundreds of hours of artist intervention to actually get there. It wasn't a simple thing. These ML filters are a long, long way from any claim that AI can make a movie. It's safe to treat any sort of overheated hype around that with due suspicion. Sure, they might make some video jobs a bit easier, but they still require a skilled operator with taste and discretion. So what about text-to-video? Over the past year or so, there's been several machine learning models that, similar to other diffusion-based techniques, can generate videos based on a text prompt. It's astonishing that they work at all, and the promise of like diffusion is that they can generate anything you can think of. The results are fun, but they're a long way from good, especially in having problems with our old friend, temporal coherence. The argument here is that even though the technology is early, it will evolve fast, like DALL-E and Stable Diffusion. It's a reasonable prediction to make, and I don't mind admitting that I had a moment of existential dread when I thought movie making would be replaced by generative models in the near future. But it doesn't hold up. From a technical point of view, the task of getting machine learning models to generate video is an enormous mountain to climb. These models will need to accurately generate a picture of the world from any precise viewpoint or angle. We're not even nearly there yet. They need to learn what is in videos and how they move over time over short time spans, also super challenging. Over longer time spans, they need to learn sequences of actions and then situate them in the world model. Each one of these is a massive area of research on its own, and combining it is no mean feat. That's not to say the general idea isn't possible. As with all creative tooling, there are clever trade-offs that can be carefully staged to make a portion of the idea possible. A 2023 paper, Diffused Heads, cleverly only trains on audio and video of talking heads. What's remarkable is the quality of the result, and that there's no prior here. It's truly generative. The faces, the mouth shapes, the timing, the expressions are all completely generated from an audio track and a starting identity frame that you use to kill for the process. In a similar spirit, the 2022 paper, Flexible Diffusion Modeling of Long Videos, is trained on a set of clips of driving around a virtual, fixed-size town or a Minecraft map. Arbitrary views and even realistic motions of driving and stopping and movement within these can be generated. There's an argument that perhaps if we make the models bigger, they'll just learn how to deal with time. I'm just not sure that's true. Video motion is just so much more complex. Taking an educated guess, based on the path of current discoveries, completely generative video models of any useful quality are just simply going to be too big for us to practically use in at least the short to medium term. However, instead, let's play this forward theoretically, and let's just assume that we can just wave away these enormous challenges around text-to-video generation, and we've somehow solved them, and we have models that can generate anything you can think of. Even then, I'd be happy to stick my neck out and say that we're still going to need a human in the loop. Because if you can do anything, you more than ever need someone with taste and a sense of aesthetics to tell a good story. Let's look at a solid example from 3D computer graphics in the movie industry again. With hundreds of hours of artist labor, massive 3D worlds can be generated, and the camera, it can go anywhere. Fast forward to 2015 and Pixar's Inside Out. Director of photography Patrick Lynn makes the decision to tie the camera to a model of real-world mechanics. The virtual lens is modeled precisely after real cinema lenses to capture their flaws and imperfections. The virtual camera is tied to a virtual camera crane that can't go anywhere that it isn't physically plausible for it to go. These creative choices are based on intuition and aesthetics and taste. These qualities are intrinsically human, and it's what helps make the look and feel of the movie so good. Image making, whether it's 3D computer graphics or diffusion, is locked in an eternal battle with the collective human ability to spot a fake. We're about a year or so into this so-called high-quality text-to-image generation, and now we've got the collective ability to pick out that washed-out mid-journey look, the mangled hands or the mismatched lighting and perspective. The quality of these models will get better so that we won't see so many of these problems, but then again, so will our ability to pick them. As always, there is creative innovation happening with clever filmmakers who are able to create videos that work around the limitations of the imperfect tooling. A recent favourite of mine is the series of Balenciaga spoofs. I'm sure you've seen them.
You are Balenciaga, Harry.
Faces are generated using Midjourney, voices using 11.ai, and the faces are animated using D.ID. But it's only the faces. The bodies are rigid, lifeless. The voices are staccato and flat. And what real-life situation has that aesthetic? Haute couture, high fashion. All of a sudden, these limitations are instead central to the look, and it just works. Similarly, Pepperoni Hugspot works with text-to-video footage. Text-to-video footage isn't low resolution, grainy, limited to clips only seconds long because they become incoherent after that. What was low-res, grainy, and full of shortcuts that were only a couple of seconds long? 80s adverts. You know what, that's not exactly true, but it's how we remember it to be true, and that's good enough. The crew really nailed the look here. The image and video generation in these examples, it's important, but there's a ton of human work here. Humans need to make prompts to drive the image to video generation, and sift through many iterations of this to find a set of media that work together. A story needs to be written that makes sense, a script too. These need to be edited into cuts that are meaningful and aesthetic. Captions and titles need to be added in post as well as music. The human is still the director here, and the complex intuition and the creativity required for that job isn't likely to go anywhere. I don't think there's any algorithm or model that can capture the subtle expressiveness of cinema, or even more broadly what we think of as film or TV or theatrical presentation. It isn't about regurgitating what is literally seen, it's about setting rules for the world of the story and knowing when to creatively break them for emphasis. It's a unique intuition that can't be described, and so a computer is going to have a hard time capturing it. Don't count out humans just yet. Thanks for joining me on this episode. I was your host, Patrick Joshi.